All right, in this next video, we're going to do problems 25 and 26. 25 is another problem list like we did in 24. And then 26, we just want to show how to, if we get into very high powers of binomial expansion, how you would find out the coefficients there quickly off of your calculator. So let's start with 25 first. We have a binomial here to the fourth power. So from our chart up on question 23, we know this row here is the fourth power, whereas this one was the fifth power. So we use this last row for our previous question. This time we're going to use this row up here, which is a 4, a 1, a 4, a 6, a 4, and a 1. So let's write that out here. We've got a 1, a 4, a 6, a 4, and a 1. And then on this one, looks like this is one of our very unfriendly ones. Looks like we have numeric values for both the first and the second term. But the nice thing is we only take it to the fourth power, so we won't have many terms. So let's take this out. First, we're going to start with this term to the fourth power. So we're going to have 2x to the fourth, followed up by 2x to the third, times 2x squared, times 2x to the first, and then the last term will not have a 2x at all. Okay. Then we're going to do our second term here, which is a 3. And when we're working through this, last time I took the second term and I started at 0 and counted up. Your other option would be take that second term over here and start at the highest power and count back down. So you would have 4 3s there, then you would have 3 3s, then you would have 2 3s, and then you would have 1 3, and then you would have no 3s there. So it doesn't matter whether you go 0, 1, 2, 3, 4, or count backwards, whatever works for you. And on this one, since it's minus, here we've got to be careful with our sign. I'm not a big fan of attaching it to each of these terms. What I prefer to do instead is, knowing that the 3 is negative, just figure out the sign for each term based off of whether that's positive or negative. So on the first term, you can see there are no 3's here whatsoever, and since the 3 is what's negative, this front term here has to be positive. So this is a plus out in front. But we're not going to write that. On this next term, you can see there's only 1 3, so you'll have 1 negative in this problem. So if you're multiplying all this positive stuff by 1 negative, that's going to be negative. On the second term, you see that the 3 occurs twice, so if you had 2 negatives, you know that's going to be a positive. And on the next one, you'd have 3 negatives, so that's going to be a negative, and here you have 4 negatives, and that's going to be a positive. So, that would be one way of doing it. Or the other way is, some people just like to know that the very first term was always positive out in front, and then the first sign between these two will be negative, and then they alternate after that. Okay, so now all we have really left on this problem is to simplify all these down. Now the variable is not very tough. The variable is quite easy. The variable is just going to be whatever power it's raised to. The hard part on each of these is all the arithmetic. So on this one here, we've got 2 to the fourth, which is 16, times 1 is 16, x to the fourth, minus, now here we've got a 4 times a 2 to the third times 3. So you've got 4, 2 to the third is 8, 4 times 8 is 32, 32 times 3 gets you 96, and then that's x to the third. Plus, now you've got a 6 times 2 squared times 3 squared. So 2 squared is 4, times 6 is 24. 24 times 9 is 216. Pretty impressive that I was able to do that in my head. Then in the next one, we've got a 4 times a 2 to the first times a 3 to the third. So 4 times 2, basically 2 is 8. 8 times 27. 8 times 27, coincidentally, is also 216. But this time it's x to the first. And the last term, we've got 3 to the fourth, Well, 3 times 3 is 9. 3 times 3 is 9. If you had 2 sets of 9, that would be 81 times 1 is 81. Okay, so there's that polynomial expanded out. Okay. Then in the last one here, again, this one we are not going to have you write out all the terms on a test. We're really just looking for the particular row out of Pascal's triangle. Like this is the 5th power. This would be the numbers you would list. Okay. On this one, we want to do it for the 10th, but we're not asking you to write out all 10 rows. That would take a long time, and most likely you would make some sort of arithmetic error along the way. Instead, we'd like to use you guys to use your calculator here and combinations. Oh, that's not a good sign, huh? Okay, so on here, we're going to use combinations. And the way the combinations work, it's NCR. And on your calculator, that's under, you have to hit the math button. Okay, so you have the math button here, hit math. And then you have to use the right arrow key to move over to probability right here in probability, and you'll see option 3 is NCR. So we'll be using that feature here. So let's write out our terms here. Our very first number, our n, is represented by our power. So this here represents your n. So this is going to be 10 combinations. Now you always start with 0. Then that'll give you your first term, which we should know is a 1, but we'll double check that. Then your next term will be 10 combinations of 1, and then you're going to keep increasing. 10 combinations of 2, 10 combinations of 3, 10 combinations 4, 10 combinations 5, 10 combinations 6, 10 combinations 7, 10 combinations 8, 10 combinations 9, and lastly 10 combinations of 10. Okay. Now, on your calculator, this is quite easy to evaluate, and again, we wouldn't need to do this very first one because we should know what 10 combinations of 0 is going to be, because in Pascal's triangle, the first number is always 1. So enter in as your calculator. You go enter the 10 first, then you go to math, move over to probability. Again, it's option number 3, which will give you 10 NCR, and then you plug in the 0. Hit enter, and you'll see that comes out to a 1. So this first term here is a 1, which we already knew. Now the second term we also should know, because the second term should match the power, so this should be a 10. And in order to do this quickly, I would recommend hitting second and your enter key on your calculator, which will recall that right away. And then you can just backspace and turn that 0 into a 1, hit enter, and you'll see, voila, that's a 10. So this next number here is a 10. Then moving down, hit second enter again, change the 1 to a 2, and that came out to a 45. Hit second enter again, change the 2 to a 3, that turns out to be 120. Hit second enter again, change the 3 to a 4, you get 210. Second enter one more time, change the 4 to a 5, you get 252. And then here something special should happen. If we change this to a 6, you'll see we get 210 again. Okay, so if this is 210, at this point we do not need to use our calculator anymore, because in Pascal's triangle, once the numbers count up and start to repeat, which they just started to, they should start to count down. So 10 combinations of 7 should be 120. 10 combinations of 8 should be 45. 10 combinations of 9 should be 10, and 10 combinations of 10 should be 1. And you could always go back and verify those on your calculator if you so choose. Okay, and again, this is all we're looking for. This is just the row off of Pascal's triangle, and this saves you from having to write out the entire triangle, this entire triangle when you're working through a power that's quite large. Okay.